Transitioning to our next speaker, this gentleman is somebody that I respect, somebody that I've had a pleasure of working with over the last couple of years, and somebody who has a really unique vision for where he sees the future going, not just in NVH, but also in the lives of students. Under this gentleman's expert leadership and tutelage, the university, Eastern Michigan University, has recently climbed 18 points in their national accreditation amongst top engineering schools. Former Ford Motor Company employee, I'd like to welcome to the stage Dr. Mohamad Qatu, who's here to talk to you about the challenges in the NVH space in the future and what's going on with electrification. So Dr. Qatu, the stage is yours.
Hi, good afternoon. Thank you very much, Gary. That was a very humbling introduction. But I'm actually mostly an academic person now. I spent quite some time at Ford Motor Company and before that at Dana Corporation. And my whole experience there was in the area of noise and vibration, as well as when I go back even to my academic training for my master's and PhD, it was pretty much in the area of vibration. So although I do not do a lot of noise and vibration work today, but I have that legacy that still is with me, and I don't think I can detach from it. And one of the reasons I'm going to show you is this journal that I serve as the editor-in-chief editor-in-chief of the journal. So I receive about 20, 30 papers every year that I have to review, and that keeps me attached and at least aware of where the industry is. But I want to also say a couple of words about who we are at Eastern Michigan University. As I think Gary mentioned, we really climbed very well in the ranking, and we are one of the top in our domain, which is regional comprehensive universities. We're one of the top universities now in the region, in the area of engineering. And one of the things we focus on and we emphasize is applied knowledge and real-life experience. I'm proud always to say that I have about 10 advisory boards in my college with about 15 members in each board serving, just to keep us aligned with where industry is and make sure that our graduates are ready to take on the next task as they move into industry. And that does distinguish us, as I say sometimes, from our big sister only 4 miles away from us, being so attached to the local community and the industry that we're serving. And the college is, it has a wide range of disciplines, but definitely engineering, mechanical and electrical, and computer engineering are core of those. I'm going to talk today about what I saw from this journal, and I'm also on the Noise and Vibration Committee for SAE that also keeps me in the loop, reviewing papers and manuscripts, although, as I said, I didn't do research myself for the past at least 5 years. So I am a little far from that, research and problem solving that I've seen with you, but I've learned a lot from the presentation I've seen thus far. The two major changes that have happened in the past 20 years, maybe a little less than that, but we definitely saw it coming. The first one is electrification, and it has come gradually. I remember 20 years ago when I was working on steering NVH, when we were moving from the hydraulic steering to electric steering, and I know some of the folks I've worked with here at Ford and before. But electrification is all throughout the new vehicles. And in fact, actually, electric vehicles, and that was a little stunning to me to find that 22% of the vehicles sold in 2022 were electric vehicles, and this is expected to grow substantially in the next 5 to 15 years. So that's a major change that has happened in industry, and all of you are aware of where that is going. And I think the biggest other thing that's happening is computerization. So and that has started way back then in the 70s at various levels, but now, we're talking even here, where artificial intelligence, machine learning, machine vision are making their way into the vehicles. Almost every vehicle that is manufactured today has some level of autonomy in it. at level 0, level 1, but almost every vehicle today actually has that level. And we expect that to continue. So those two direct changes that happened in the last 20 years, I think, are there to stay with us for the indefinite future as we move forward. And thus, in the area of NVH, and again, based on the assessment I've had, reviewing papers and so on, these two changes had, particularly the first one, had a significant impact on the noise and vibration signature and characteristics of a typical vehicle. So here's what basically I think I'm finding from literature and from research. The main sources of NVH in an internal combustion engine vehicle are known. Usually we classify them into these 4 categories, right? Powertrain, road and tire, and wind, and then other, mostly electromechanical devices. And you can add more probably, but these are the main sources of noise. There's one thing that has gone through a significant change, and that change impacted the others, as you'll see in a minute, and that is definitely the powertrain. The powertrain is no longer the internal combustion engine. It is now an electric motor and has a transmission usually that has its own characteristics. And that actually creates different expectations for the noise and vibration and harshness that you get from the vehicle. So some of the characteristics that you're going to see that in electric vehicles, there's low noise overall levels. The internal combustion engine, usually as compared with electric motors as main source of power, produces far more NVH signature than an electric motor does. But that does bring with it that the masking of other NVH phenomena that's happening is now much lower. So other NVH signatures are becoming now more prominent. The other thing is that the orders of a motor are usually at higher frequencies than that of the internal combustion engine, which actually does create its own set of changes because it becomes more tonal in nature, and it does excite a different set of frequencies that historically were more difficult to simulate. If in just about any structure you analyze, it's usually a lot easier to simulate and find low frequency ranges or low natural frequencies than you do for higher natural frequencies. You need refined meshes. You need more time to actually get the higher frequency, natural frequency that can be excited by electric motors now instead of the internal combustion engine. And the other thing is that, the other thing that's becoming more and more clear, I think, is that sound quality becomes very important from various angles of it. The tones, the sharpness that come with the electric motor is significantly different, and thus the ear tends to tune to it more, and it becomes more annoying. The other thing that comes also with that NVH signature is the psychoacoustic nature, or the subjective evaluation, that becomes more and more important. Sound all of a sudden is not only, we dealt with it for most of our lives when we deal with NVH as an unwanted, in fact, the word noise in noise, vibration, and harshness may be defined as unwanted sound, right? So it's not something that is desired. We want to suppress all the time. All of a sudden now with the electric vehicle, sometimes we want the sound to actually produce the sound quality that we're looking for. So it's actually almost like a reversed approach. So sound quality becomes more important than typical noise level assessments that we had before. So as always, we begin with the assessment with the receiver, and that's what I think these are some of the things that will remain with us. The source transfer path receiver analysis is there. The same thing with the V system design. There's a lot of work that needs to be done at the component level. And when I say work, we want to depend more and more on simulation, even at the component level, as we move forward. And as I will maybe talk to in a couple of minutes, the pressure of time is pressing us to produce vehicles at a faster pace. And we can't always build prototypes. I remember 20 years ago when I started at Ford, or more than 20, 25 years ago when I started Ford Motor Company, we were working with AP2s and AP4s. I think some of the people who had that experience probably remember those. And they are very time-consuming to produce an AP2, test them, assess, make some changes, go make the changes in the prototype, and then assess the changes, optimize experimentally. That is no longer a valid approach if we have a time crunch from concept to production in those vehicles. So we're going to depend more and more on simulation, both at the component level and then at the subsystem level, and hopefully, and that's the point probably of the whole thing here, zero prototypes. And I think we probably will need still confirmation prototypes towards the end, but hopefully no more than just that. CAE is still a very important tool, although I think the tool needs to be modified. As I mentioned before, the exciting frequencies that we have now with the electric motors are different than the ones we had with the internal combustion engine. So we need to come up with tools that can actually give us a good spectrum of frequencies that are dependable and accurate. And that's easily said, but when you look at the CAE and what they do, usually the doubt grow bigger when you are starting to assess frequencies that are higher. And then, so we still depend on testing. We probably, as time passes, we bring more advanced CAE tools that our dependence on testing become less and less, and we approach the goal here of zero prototypes, as we are seeing. So the other thing is that, the typical powertrain noises exist. Of course, we have an electric motor that has its own characteristics. It has its own structure that is different than an engine structure. There is a radiated noise coming from it. There's a structural bore noise coming from it as well in terms of your transfer path. There is transmission gear characteristics that is also different. But also, all of this is impacting the other noises, like the wind noise. For example, electric vehicles, usually because of drag, to minimize drag, tends to have a different wind noise characteristics, where the wind actually is more laminar than turbulent. But you may still have turbulences in certain local areas. So it actually, and even when you go to road and tire noise, the electric vehicles still are 20 to 30% or maybe even more bigger in weight, which actually the structure itself needs to be designed differently, and the chassis and so on and so forth to accommodate the extra weight that we have, which again impacts your road and tire noise signatures. And with the electric vehicles, there's more dependence on the electric batteries or the electric system. So you're going to find more and more electric subsystems or inside an electric vehicle than we usually have. What became important, or is becoming more and more important as we move into electrified and computerized vehicles, is active sound systems, and that actually is replacing the normal combustion engine sound. And it is, there are a lot of things to think about because you need to alert the public. So you may generate sound to actually alert the public about the electric vehicle that's passing the road. And that may actually be directional towards the sidewalks, for example, and then you've got to rethink your brand strategy. All of you probably recognize that the signature, the noise signature, whether you want to amplify particular orders like the 1.5 order or the 3rd order in a V6 engine, is actually a part of the noise branding. Now that has to be rethought and reevaluated as we have electric vehicles. What kind of sound should we generate that actually is compatible with the brand that we want to have for the particular vehicles? And the same thing applies to the exterior as well as the interior for sound cancellation or sound masking or even sound generation. Because of the extra weight that we have with the electric vehicles, we need to think of low-weight NVH solutions as we move forward. These are the fundamental elements, and I think this is probably the last slide I have. Most of the time, this is a very fast-growing industry, the electric vehicles in general, and autonomous vehicles, and so on. That requires a fast concept to production approach that requires us to rethink the tools we use to design vehicles. So we need to think of advanced testing, advanced simulation tools, creating components that can be used in multiple vehicles to minimize, again, the time to production, develop testing and simulation libraries of components so that we can have them accessible at our fingertips, embed technology that can be used in noise cancellation, sound generation, and other possible applications. And as we move forward, the direction is really for us to all go into becoming an industry with zero prototypes. Thank you all very much.
Thank you very much, Dr. Qatu. Appreciate your time and expertise here. If it's all right, I'd like to ask you a question. First of all, are there any questions out here for the good doctor before I ask mine? Dr. Qatu, during your time at Eastern Michigan University, I think you've also aligned the student experience to be able to support the jobs of tomorrow with some recent investments that you've made, not just in NVH, but in also vehicle dynamics. I also think the university is looking for potential research collaboration and partners. Would you like to expand on that for just a second?
Yeah, absolutely. I think we were very blessed with being generously funded, I should say, by private partners. I'll give two, maybe three examples, but I want to focus on two here. We are called GameAbove. GameAbove is a group of our own graduates from many years ago who really did well in life, and they formed this group. They called themselves GameAbove. And it's kind of a cute name. I don't know if it's cute enough for an academic institution or an academic entity, but they called themselves GameAbove because many of them were athletes, actually. But they did well in life, mostly in technology, interestingly. And they gave us good gifts. We also had actually a great partnership with Jack Roush. Jack Roush himself was a graduate of EMU, and he really did give the college a very generous gift as well. So we were well funded to establish new labs, and we are very proud to spend quite a bit. Actually, and I should give credit actually to VI Grade and to Gary here, because a part of the gift that a part of the lab, the new lab that we developed several new labs like virtual reality, even combustion engine, and robotics and several others. But one of them is NVH and vehicle dynamic simulation, and we did fund that partially from funds we got from Jack Roush actually for this particular lab. But we want to also thank Gary and VI Grade, because I think we got, as an academic institution, we got a substantial gift from them. I think 2/3 of the equipment, of the cost of the equipment, were actually gifted to us from VI Grade. So we really appreciate that. And they are, as I said, we're really proud of the fact that we are producing engineers. Our employment rate is about 100%. They're actually, the starting salaries are becoming above average in terms of where they start, our own graduates. So I think our constituencies, the industry, is seeing the value of employing our graduates. And I think a lot of that credit goes to the fact that we have established those labs and our students generate this applied experience. and definitely having access to VI grades. We have a vehicle dynamics simulator and an NVH simulator that our undergraduate students get exposed to as a part of their education. So we're very thankful to that, Gary.
Cool. Well, again, Dr. Qatu, thank you for an excellent presentation. Thank you, sir. Appreciate it.